Okay, and since you can add two antiderivatives, why not subtract them? So if you're subtracting two functions, you want to find the antiderivative, why not just find the antiderivative of each and just subtract whatever you get? So antiderivative of 1 over x squared minus 1/2 x to the fourth. Again, we can call this our red function and we can call this our blue function. We will just find these two separate antiderivatives, and then whatever that is, that'll be our answer. That did not look like a good antiderivative symbol. Let's try that. Actually, we'll just leave the original. Try to just trace it out. Okay, so let's take the antiderivative of both of these. Now, remember step 1 we haven't really done much with. We're going to this time. This is not in power form. This looks like a rational function. We can rewrite this as x to the negative 2. That way it looks more like a power, and we can use the reverse power rule. The other one was kind of already in form. Okay, but again, we're going to split that up into two antiderivatives. I'm not sure why I didn't show that, but I'll show it now. So we're going to find the antiderivative of x to the negative 2. We're going to subtract, and we might as well pull the 1/2 out because of the constant multiple rule for antiderivatives. 1/2 to the fourth, and don't forget our dx. I said 1/2, I meant integral of x to the fourth. So the 1/2 out in front, and then x to the fourth inside the integral. Now we'll just find both these antiderivatives and subtract them. So to find the antiderivative of x to the negative 2, even though it's a negative exponent, we still add 1 to it and divide by that. So when you add 1 to negative 2, it becomes negative 1, and then negative 2 plus 1 is negative 1 on the bottom. Eventually we're just going to make that the coefficient, so it'll be negative 1 times x to the negative 1. On the right, again, we can just leave the 1/2 out front and take the antiderivative of the inside. Whoops. So the antiderivative of that is going to be x to the 5th over 5. Let's see if we can move that a little bit. Okay, that doesn't really matter, I guess. So x to the 5th over 5, and then again we still have that original 1/2 in front of the antiderivative sign that we need to include. I keep saying integral. It means the same thing as antiderivative. Just right now we're using antiderivative, but you'll learn that the indefinite integral is the same as antiderivative. Okay, so now that we've done that, we just need to simplify this. Don't forget your plus c. Obviously this is going to become 1/10, and over here, like I said, it's going to become negative x to the negative 1. Depending on who your teacher is, they might make you rewrite that as a fraction. So negative x to the negative 1 will become negative 1 over x. Like I said before, that will become minus 1/10 x to the 5th plus c. So we've just basically shown that the integral of what we were given is equal to negative 1 over x minus 1 over 10 x to the 5th. It's kind of weird because a lot of times your antiderivative doesn't look much like the function they gave you, but that's okay. You can still check it by taking the derivative of your answer, and hopefully you'll get the original back. And that's all this particular slide is doing. I'm not going to spend too much time on it. You guys are getting really good at this by now, to where you know your derivative rules, and you'll notice that finally you get the original function you started with, namely, well actually this is the original one. Once you finally convert it, you'll get 1 over x squared minus 1/2 x to the 4th, which is what you started with. And again, the derivative of c is 0, which is why it goes away. But it's also why we need to include it in our antiderivative answer.